Hi everyone. We are getting ready to start Module 1 of our brand new book. We're switching over to the Math 2 book. But before we do, there's one lesson I want to add in before we get started. So this is kind of like starting Module 1, but it's not out of the book. We're going to do a worksheet instead of book problems. I just wanted to take one day to talk to you guys about the Pythagorean theorem and make sure you guys know what it is and how to use it. So first of all, Pythagorean theorem is all about right triangles. There's some vocabulary you need to know. And we say in a right triangle, first of all, every triangle has three sides. That's what makes it a triangle. Now, in a right triangle, the one side that is opposite from the right angle, we have a special name for that. It's called the hypotenuse. That's a very important word. Make sure you remember that one. And I added in parentheses there, it's also the longest side of a right triangle. So you'll know if you happen to see a triangle and you see that one side is a right triangle and one side is the longest, that one's automatically the hypotenuse. Now the other two sides are just called legs. We don't have separate names for them. They're just both the legs. So every right triangle has one hypotenuse. That's very important, opposite the right angle. The other two we call legs. And here's a picture. And the reason that the one side is labeled hypotenuse is because, see here, the red box is the right angle. If I find the right angle and I go across to the opposite side of the triangle, that's always the hypotenuse. Now, once you found the hypotenuse, the other two are just legs. That's easy. It doesn't matter. There's not like one leg and another leg. They're just legs. Now, we need to know that vocab to learn the Pythagorean theorem. So the Pythagorean theorem is actually a formula that lets you find one side of a right triangle if you already know two of them. And the formula is a nice, easy one to remember. A squared plus b squared equals c squared. Very, very common, very important formula. You want to remember this one. So that one's called the Pythagorean theorem, and it says a squared plus b squared equals c squared. Now, a, b, and c are the sides of the triangles, and the one thing that's really, really important for Pythagorean theorem is that the c has to be the hypotenuse. So anytime you're using the Pythagorean theorem, make sure you put the hypotenuse over here. Now, A and B are the legs, and just either order. It's not like one has to be A and one has to be B. They are the legs. Put either one in either spot is fine. Now, an interesting thing happens when you start solving. When you're solving a Pythagorean theorem equation, because all variables are squared, you have A squared, you have B squared, and you have C squared. What you want to do is when you get to the end, whichever one you're solving for, A, B, and C, it's always going to say A squared equals or C squared equals. Now when you get to that point, you can cancel out a squared using a square root. Those are inverses. So I said, for example, and I don't know why that x equals 4 popped up early, ignore that for now. But I said, for example, if you had x squared equals 16 and you wanted to solve it, the step to do that would be this right here. You would take the square root of both sides. Now remember, when you're solving an equation, you can do anything you want as long as you do the same thing to both sides. So I did a square root on this side, I did a square root on this side. You're allowed to do that. Now over here, this is the important part. When you have something with a squared on it, and you take a square root, those cancel each other out. They're gone, and it just leaves whatever that variable was. That's how you turn an x squared into an x, or an a squared into an a, or whatever. Now over here, we'll talk more about radicals later in the year, but the square root of 16 is 4, and you can use a calculator for that part. I'm not real big on working on square roots yet. We'll cover that more later. For now, just grab a calculator and type square root of 16, and it'll tell you the answer is 4. So let's do an example. What we have right here is a right triangle, and I know it's a right triangle because I can see the right angle in it. And I said, in this triangle, I want you to find the length of the third side. And when I say the third side, what I mean is two of them are marked. One of the sides is a 4, one of the sides is a 13, This side I don't know, so I want you to tell me what that question mark is. How long is that third side? Now I just finished telling you, if you know two sides of a right triangle, you can always find the third one using the Pythagorean theorem. So let's do that. Let's start with our formula. A squared plus b squared equals c squared. And remember, you got to make sure you put the numbers in the right place. So two of them we're going to put numbers in for. One of them I'm going to leave A, B, or C. Just leave it. And we're going to solve for it. So what we need to do is figure out which one is which. So when I look at my picture, I find the right angle. I go across. The question mark is the hypotenuse. That's the one I'm trying to find. So that's the one I'm not going to substitute a number for. I'm going to leave that one as c squared. Now the legs are a and b, so I'm going to put the 4 and the 13 in for a and b. And remember what I said, it doesn't matter which one comes first. You can say 4 squared plus 13 squared, or you can say 13 squared plus 4 squared. It doesn't matter. So I'll just do 4 squared plus 13 squared. And now we're going to do the work. We're going to solve for c. Now 4 squared plus 13 squared, those are just numbers. 4 squared means 4 times 4, that's 16. In fact, I'll even put that in. You're welcome to use a calculator for this though. 13 times 13 is 169. Add it together and you get 185. So I've gotten to the point where I'm not done with the question. I haven't solved for c yet, but I solved for c squared. So remember what I showed you on that last slide. If I want to cancel out, if I want to turn something squared into just that variable, if I want to cancel out the square, I do this. I take the square root of both sides of the equation. Now on the right hand side, the squared and square root just cancel out and leave c. On the left hand side is actually the answer to the question. So what I'm going to do now is I'm going to grab a calculator, I'm going to type the square root of 185 in, and I'm going to see what I get. If I get a decimal, I'll just kind of round it off. So I'm going to pause it and do the calculator work. I'll be right back. All right, I'm going to call it about 13.6. When I did that on my calculator, I'm going to round it off and say it's about 13.6. Now to double check my answer, remember I said the hypotenuse is always the longest side of the triangle. So my answer should have been bigger than both 4 and 13, and it is, just by a little bit, but a little bit's enough. The hypotenuse is 13.6, it's the longest side. So I did a squared plus b squared equals c squared. I put the numbers in the right place. I did the work. I used a calculator for the square root part. I got my answer. All right, for our second example, I'm going to do the exact same problem with you, but I'm just going to move one of the numbers. So what I did, remember in the first example, the 13 was at the bottom and the hypotenuse was blank. So for this one, I just took that 13, I moved it up. Now, the question actually ends up being a little bit different. The numbers are the same, but you'll see how it works out. It's still a Pythagorean theorem question, so I'm still going to do a squared plus b squared equals c squared. Now the difference is when I go to find the hypotenuse, this time the hypotenuse is the 13. So the 13 has to go here. Last time the hypotenuse was the question mark, so I left that one as c and I plugged in numbers for the legs. This time the 13 has to be c. Now the a and the b are the legs. One of them is 4, the other one is what we're trying to find. And like I said, it doesn't matter. Plug in the 4 for either one, leave the other one. So let's leave the a squared and put the 4 squared here. And now let's finish solving. So I'm going to do the squaring part. It's actually the exact same numbers we just did. 4 times 4 is 16. 13 times 13 is 169. Now this time, last time the 16 and the 169 were on the same side of the equal sign. I just added them together. This time we're equation solving. So I need to cancel out the 16. I'm going to subtract 16 from both sides to cancel. It's a 6 right there. And that one does cancel. and it leaves just the a squared. And this time, 169 minus 16 would be 153. Now we're going to do the same step to finish. Well, once I get to the point where it says, in the first question it was c squared equals something, so I divided or I square rooted. This one is a squared equals 153. I'm going to cancel out that squared with a square root. And when I do that, I get just a. And my answer is square root of 153. We'll do that on the calculator again. I'll pause one more time and come back. All right, that one comes out to about 12.4. And if you want to check your work again, kind of like we did in our first one, you look at it and you go, okay, well, the hypotenuse should be the biggest side. And this time the hypotenuse was the 13. So my answer should come out less than 13, and it did. So you can kind of double check your work. You can catch mistakes that way. If you're trying to find the hypotenuse and you end up with a number that's not the biggest of all the three sides, then something went wrong and you got to check your work. Or same thing here. I was actually finding a leg. If this number had come out bigger than 13, then I know I made a mistake and I got to go back and check my work. But that's basically how Pythagorean theorem works. It's always a squared plus b squared equals c squared. The hypotenuse has to be c, whether there's a number like this, like the 13, or whether it's the thing you're trying to find and you just leave it as c. Then you do the work. And you always end up by taking the square root of both sides to cancel out a square and finish the question.